Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is the database design concepts, in the same chapter, that is chapter number 4, that is the intermediate SQL. In the last class we have discussed some topics of the intermediate SQL, that is how to use the intermediate SQL, or what is the main advantage of using the intermediate SQL, what is the main reason of why we are using the intermediate SQL. We have covered the topic like views, how to view the definition, view the we can say that view the target of the database, that is a view of the database. So let's start with the previous class session, then move to the today's session, that is the next part, that is the today's topic. So let's start with the previous class session, that is the views, that is how to make the view, or how to view the transactions, how to view the database in a efficient manner, that is a different views that is available in the database. So in our example, that is we are operating on the high level object, that is how they are operating as a logical model level. That is, we have assumed that the relations in the collection we are giving are the actual relation that is stored in the database. So how it is that possible? That is a query that is used, that is a select name, department name, ID from the table instructor. So these are the three columns that is available from the table instructor, that is the ID, name and the department name. Also it is using that the next query, that is it is using the where clause, and there are three conditions. What is the condition? First of all, where the course ID equals to section.course ID, as well as the course department equals to physics, and the section.semester that is equals to fall, and semester.year that is equal to 2009. This is one of the query that is used. So it is possible to compute and store the result of the above queries and then make the stored relation available to the users. That is how to use the queries, how to make the queries, or how to done the queries that is available in the user, that is related to the user, that is available to the various relations. However, if we did so and the underlying data in the relation instructor course and section changes, the stored query result would then no longer be required or match the result of the re-executing the query that is available on the relations. Then there is a view definition, that is how to make the view, how to view the definition that is available, that is a there are different views definition that is available. So one of the main command that is available is the create view, that is a create view command. So this is how to create the different views, that is simply take the instance of the view, or how to create the different views of the database, that is a different databases that is required. So what this is one of the, that is a create view, and name of the view is v, for example, as query expression. So what is a query expression? What is a query that is given? So this is the create view v as the query that is a select for example star from the table instructor. So this is create v as select star from the instructor. So this is one of the view that is created. So query expression is any legal query expression. For example, we are giving the query that is select asterisk, that is a star from the table employees, from the table instructor. So it is using the query that is a legal query expression. This is another example that is taking, or that is making, or that is taking the query, or that is creating the view that is a faculty as what is the query name, that is taking the ID, taking the name, taking the department name from the table instructor. So these are the views that is available to create the view faculty as select the ID, name, department name from the table instructor. This is again the one of the example that is discussed, that is the physics fall 2009 as select course ID, section ID from the tables course and the section, and this is the condition, that is course ID is matched with the course ID and the department name, semester and the year is matched with the department year, or department name, semester and the year. The next one is using views in the SQL queries, that is how to use the views, or how to use different views in the SQL queries. This is select course ID physics fall 2009 where building equals to Watson. So this is how to use the views in the SQL queries, or how to get the views in the SQL query, that is how they are using in the SQL queries. This is one of the example, that is the attribute names can be specifically or specified explicitly as follows. So we can specify the tables, we can specify the rooms, so we can specify the attribute name, that is a view that can be specified explicitly as follows. This is create view department total salary, and this is the these are the two we can say the attribute that is used, as this is the query expression that is used. The preceding view gives for each department the sum of all the salaries of all the instructors at that department. Since the sum salary does not have a name, the attribute name is specified explicitly in the view definition. This is again one of the same example that is discussed. Then we discuss about the materialized view, that is the next category, that is how to use or what is a materialized view. So if I want to update the information, that is if a view is created and the database is created. So for example, a view is created from the database, and if there is any changes in the database, then the view must be updated or view must be up to date with the change in the database. That is known as the materialized views. That is a whenever any material, whenever any change, whenever any updation that is required in the database, that must be updated in the view, must be up to date in the view, that such views are known as the materialized view. For example, consider the view department total salary that is taken, or we are taking the salary, we are taking the department, we are taking the manual method that is used for taking the queries. So the department salary is materialized, its result will be stored in the database. So if any item is stored or deleted or added or deleted from the instructor table, the result of the query defining the view would change, and as a result the materialized view content must be updated. That is how to materialize the view content, that is how it is available in the view content. Then next is that is a materialized view, how it is maintained, that is a view maintenance is required for the materialized view. Then we will discuss how to update a view, that is how to make the changes or how to update the different view that is available in the database, that is the updation of a view. So all the views are a useful tool for the queries. They present serious problem if we express updates, insertion or deletion with them. So if I want to update anything, that is a insert, delete or update any information, so there must be a problem. The difficulty is that if there is any modification in the database, that must be translated into the actual relation into the logical model of the database. That is, first of all, it is changed into the logical model, it is changed into the logical schema that is available in the database. For example, this is the value that is inserted into the faculty, that is the updation, or we can say the addition that is available. This is how to insert, or that is the insert into the faculty, that is the faculty view. What are the values? That is the value is changed. So it must deal with the various approaches, or there are multiple approaches that is available in the relation. And these are the various updatable information that is we can update, that is a from clause, select clause, notional clause, update, insert and the delete clause. Then we have discussed about the transaction, that is what is the usage of transaction, how the transactions is used. Now the next topic that we have discussed is the transaction, that is how to use the transaction, what is the usage of transaction, and how to maintain different transaction, what is the category of different transaction, or what is the usage of using the transactions. So a transaction consists of a sequence of a query or the update information. That is, different sequences are maintained. That is a sequence of a query or the update statements. The SQL standard specifies that a transaction begins implicitly when an SQL statement is executed. That is, a SQL standard specifies, or that is a SQL is used that a transaction begin implicitly when an SQL statement is executed. So whenever an expression or whenever a SQL statement is executed, that must begin, or that must transaction begin very implicitly. One of the following must end the transaction. That is, there are two methods by which we can end the transaction. That is the end of the transaction. That is, the transaction has gone. There are two methods. One is the commit work, one is the rollback work. That is, there are two conditions. One is the commit, one is the rollback. When we use the commit, that is commit the current transaction, that is it makes the updates performed by the transaction become permanent. So when we do the, or when we click on the, or when we operate the option commit, that means it updates performed by the transaction become permanent in the database. And then rollback, that causes the current transaction to be rolled back, that is undo each and every operation. That is, if I am not saving any data, that undoes the operation, that undoes all the updates that is performed by an SQL statement in the transaction. Therefore, the database state is restored to what was before the first statement of the transaction was executed. So rollback means again going back to the first statement or the first execution phase, and the commit means making the changes, making the updates that is performed by the transaction. Then we have also discussed about the integrity constraint, that is what is the integrity constraints, how it is available in the integrity constraints. So let's start with this session, that is how to use the integrity constraint, that is how to get the integrity constraint. So these are the various integrity constraints, that is we are defined the value null, we are defined the value instructor ID department, and the budget that is greater than the $0. That is we are the or integrity constraint means the changes that is made to the database are done by the authorized user, that is not result to a data consistency. So whenever we apply any data, whenever we apply any change that is made to the database by the authorized user, that does not result into the loss of the data redundancy or the data consistency. So if the data consistency has been removed or there is a loss of data consistency, that is there is a lack of the integrity constraint that is available. So integrity constraint means the proper manner, proper updation that can be followed by the integrity constraints. Therefore, the integrity constraints guard against the accidental damage to the database. Now, what are the examples of integrity constraints? These are the examples that cannot be a null. No two instructors can have a same instructor ID. Every department in the course relation must have a matching department name in the department relation. Then we have discussed that is how to use the constraints on a single relation. So these are the three values, that is how to maintain the constraints on a single relation. That is a not null, that is a unique, that is a check. These are the three relations, or these are the three constraints that is available on a single relation. That is a not null values, unique values, and the check values. This is a not null constraint that is available, that is we are applying that there is a no null value, that is a not null value. The not null specification prohibits the insertion of a null value for the attribute. That is, if any entry will be, we can say the empty, that is a null, that is not taken by the name, or that is not taken by the database. That is a not null value is specify the insertion of any null value for the database. So if there is any null value that will give the error or that will prohibit, then the null value cannot be entered into the database. That is a not null constraint. Then there is a unique constraint, that is this is a constraint that means every entry is unique, there is no duplication of the entries. Then check clause, that is also used, that is used to ensure that the attribute value satisfies certain conditions, in effect creating a powerful type system. For example, a clause check in the table or create table command for the relation department would ensure that the value of budget is non-negative. That is a check clause. We are checking the clause, we are checking the different part that is used with the check clause. Then referential integrity, that is one relation for a given set of values also appear for a certain set of attributes in the other relation. That is the referential integrity. That is a one table will be referred to the another table. Right. Then how to integrity constraints violate during a transaction. So there are different we can say the different method that will be used to violate the various transaction method. That is, a constraint says that the spouse attribute must contain a name that is present in the person table. Then complex check conditions and assertions, that is how to use the or how to apply the check or complex check conditions and the assertions. This is a check value, this is a check constraint that we have discussed. Now next is SQL data type and the schema, that is what are the various data types that is available in the SQL, that we have already discussed in chapter number 3 in just we can say the introduction. So that is a SQL or SQL data types and the schemas. So let's start with the today's session, that is the today's class session. That is what are the SQL data types and what are the schemas available in the SQLs. So in chapter number 3, we covered a number of built-in data types that is supported in the SQL. So in chapter number 3, we have discussed about the various data types that is available in the SQL, such as integer type, real type, character type. So these are the three values that is available. These are the three data types that is available that is supported in the SQL. That is the integer, real, and the character. There are additional built-in data types supported by SQL, which I will describe below. We also describe how to create user-defined types in the SQL. That is how to define or how to create the basic user-defined types in the SQL. That is a structured query language. So the first part is the 4.5.1 is date and the time. Date and the time. Okay, Nelda, you take the 2 minutes. I will wait for you. So except that the or except from the basic data types like integer, char and the real type, there are some additional data type that is also supported by the SQL, that is a date and time data type. So one of the example is a date and time that is available, that is a date and time types in the SQL. So in addition to the basic type that we introduced in the 3.2, that is in the third chapter, the SQL standard supports several data type that is relating to the time and the date. So there are different data functions also, data types also that is available in the SQL. That is several data type that is relating to the dates and the times. The first part is date. That is a calendar date that contains a 4-digit year, a month, and the day of the month. That is a 4-digit month year that is available, 2-digit month, and the 2-digit day that is available. For example, 2004 month is 12 and the date is 31st. That is 31st December 2004. Then the time, that is the time of the day in hours, minutes and the seconds. A variant time can be used to specify the number of fractional digits for the seconds, that is by default it is 0. It is also possible to store time zone information along with the time by specifying the time with the time zone. That is a time attribute, that is a time type that is available in the SQL. Then there is a timestamp, that is a combination of the date and the time. That is a timestamp is available that can be used to specify the number of fractional digits for the seconds. Then date and time values can be specified like this one. This is the date, that is 2001. As I give you example, this is the time that is in the hours, minutes and the second. This is the hour, 9 hours, 30 minutes and the 00 seconds. Then the timestamp that is also available. Dates must be specified in the format year, followed by a month, followed by a day. So date must be specified in the same format that is available in the format year, that is followed by the month, that is followed by a day as shown above. The second field of time or the stamp can have a fractional part as shown in the timestamp above. So how it is used? That is used with the timestamp that is used. So that will be used to show that the timestamp variable will be used to show the timing. That is this is the expression that is how to show the timing. So seconds of the time or the timestamp can have a fractional value. This is the fractional value that is given. It is 0.5. This is the fractional value that is a 1.5 as a part of the timestamp above. So this is just example. Now, what are the default value that is available? So SQL allows a default value to be specified for an attribute as illustrated with the following create table command. So SQL also allow a default value that is to be specified while using the transactions, while using the method that is used in the SQL. So SQL allows a default value that is specified for an attribute as illustrated in the following create table statement. So first is the example is create table student. So one of the table that is created is the student. Then what's the field name? First of all, first field name is ID, that is a varchar type that takes 5 characters or the 5 digits. The name, that is also varchar, but that is not null. That is the user cannot give the blank spaces. You cannot make the blank spaces in the name field. That is, there is no blank space that is available in the name field. Then department name, that is of also the varchar 20. Then total credit, that is of numeric, that is there are 3 numbers without any decimals, that is a total credit. So it is also specifying that there is no we can say the decimal value that is available, because it is available 3,0. So there is no duplicate value that is, or there is no decimal value that is available in the total credit. Then default 0. Then there is a primary key. So what is the primary key in this one? There is a ID, that is the primary key of the this table, we can say. The default value of total credit is declared to be the 0. This is the default value of the total credit. As a result, when a tuple is inserted into the student relation, so whenever any row is inserted into this table, if no value is provided for the total credit, its value is set to be 0. That is a by default value. If no value is given to the total credit, automatically takes the value as a 0. The following is insert statement illustrates how to insert can or how to insertion or how an insertion can omit the value for the total credit attribute. So this is insert into the student ID, name, department name. So this total credit field is missing. The user has forgotten that there is a total field also, or total credit also. So he or she cannot insert the data into the total credit. He or she simply digs the data, takes a column into three format, into three parts. That is the ID, name, and the department name. So what is the value that is inserted? That is a 12789. Then what is the name is Newman, and what is the department name is computer science. So ID is 12789, then the name is Newman, and the department name is computer science. Right. So these are the default value that is given, that automatically it takes the total credit value as a 0. Then index creation, that is how to create the index, or that is the index creation. That is how to create the index, that is the index creation. So many queries reference only a small portion of the records in a file. For example, a query for find all the instructors in the physics department, that is find all the instructors that is available in the physics department, or find the total credit value of the student with the ID 22201. So find all the instructors, find all the total credit value that is available with the ID 22201. That is references only a fraction of the student records. It is insufficient for the system to read every record and to check the ID field for the ID 32556, or the building field for the value that is a physics. So this is a ID field that is available, that is a 32556 for the building that is available as a physics. So index is on an attribute of a relation, is a data structure that allows the database system to find those tuples in the relation that have a specific value for that attribute, that is efficiently done without scanning through all the tuples of the relation. So what is the index that is available? That is available on an attribute of a relation, that is a data structure that allows a database system to find the tuples in the relation, that is how to, or what are the various tuples in the relation that have a specified value for that attribute efficiently, without scanning through all the tuples of that relation. That is, without scanning, what will be done? That is done through the tuples of the relation. For example, if we create an index on an attribute ID of relation student, the database system can find the records with any specified ID value such as 22201 or 44553. So what is the index? Simply like a tag in the notebook. We have applied the tag in the book or the notebook where we finish the last reading, and then continue with the same reading. In the same way, there is an index that is available in the database to simply identify or refers to the last word or the last relation or the last we can say the entry that is made into the database. Or simply whenever I want to index anything, judge anything, pinpoint anything, that can be done by the index creation. This is create index student ID index on the student ID. So the above statement creates an index named student ID index on the attribute ID of the relation student. When a user submits an SQL query that can benefit from using an index, the SQL query processor automatically uses the index. For example, given an SQL query that selects the student tuple with ID 22201, the SQL query processor would use the index, that is the student ID index, that is defined for the required tuple without regarding the whole relation. Now next is the large object types. So how it is using the large object types? By using the character data, that is a globe, or the binary data, that is a blob. So there are two methods that is used, that is the globe and the or the blob. The letter lob in these data types stands for the large objects. For example, when we declare the attributes like book review globe, that is the character data, that is of the long type, that is a long object. Then the binary data that is also available, that is a blob, that is the image that is in the binary terms. Then what are the user defined types that is available? That is also data type that is available, that is defined by the user. So SQL also supports two forms of user defined data types. So there are two forms of user defined data types, that is the user defined, that is defined by the users. The first form that is covered here is the distinct type. The other form, that is the structured data type. So there are two types, one is a distinct type, one is the structured data type, that allows the creation of complex data types with nested record structure. That is the how to use the creation of the complex data type that is available with the nested record structures, arrays, and the multi sets. This is a distinct type that is only taking the unique value, that is a distinct type. So the create type clause can be used to define new types. For example, the statements, if I want to create a type, that is a create type dollars as numeric 12 to final. So this is a creating the type that is a dollar that is available as a numeric value, and this is 12 and the 2, and then there is a final, that is a final value that is available. That defines a user defined types. That is this is a user defined types. So these are the dollars and the pounds to be decimal numbers with the total of the 12 digits, two of which are placed after the decimal point. This is a 2, so two numbers or two digits are placed inside the decimal point. The keyword final is not really meaningful in this context, but is required by the SQL for the reason that we get into the implementation. For example, we can declare the department table as create table department. There is a department name, that is of varchar 20, building, that is of varchar 15, budget, that is of dollars. SQL also provide the drop type and the alter type clause to drop or modify the types that is available in the field. This is also creating the domain. This is the support for the types and the domain database implementation. Then next is create table extension. That is what is the create table extension, or what are the various values that is available in the create table extensions. So applications often require creation of the tables that have the same schema as an existing table. So that requires how to create the table that have the same schemas. So SQL provides a create table like expression to support this task. That is a whatever the application that requires the same table creation every time, the same schema, the same structure, the same logical design of the existing table. So SQL provides a new method, provides a method that is a create table like extension to support this task. So one of the extension that is available, that is a create table like extension, that is a create table. For example, create table temp instructor like instructor. So creating the one more table, that is a temp instructor, and this is just like a instructor table. So this is create table temp instructor like instructor. The above statement creates a new table that is a temp instructor that has the same schema as an instructor. When writing a complex query, it is often useful to store the result of a query as a new table. The table is usually temporary. Two statements are required, one to create the table and the second to insert the query result into the table. So there are two statements that is required, that is the how to create the table, and second one is to insert the query result into the table. For example, the following statement creates a table T1 containing the results of an query. So how to create the result, what are the various results that is available in the query. So this is create table T1, that is creating the table T1 as this is a statement that is available. Select star from the instructor where the department name equals to music with the data. By default, the names and the data types of the columns are inferred from the query result. Names can be explicitly given to the columns by listing the column names after the relation name. Now next is schemas, catalogs, and the environments. That is what are the schemas, what are the catalogs, and what are the various environments. Then next is the important part, that is the authorization. That is how to authorize or how to identify that the user is an authorized user or not. So authorization in simple terms is the verification. In simple terms, it is a tool to identify or to manage or to we can say identify there is a risk involved or not. So we may assign a user forms of or user several forms of authorization on the parts of database. There are several forms of the database, several forms of the authorization on the parts of the database. Now authorization can include authorization to read the data, authorization to insert the new data. So there are different authorization that is available. One authorization is that is for reading the data. One authorization is how to insert the new data. One authorization is how to update the existing data. Next, how to delete the data. So one is the read out, one is the update, one is the insert, one is the delete. Each of these authorization is known as privilege. So whenever we are using the authorization for reading, inserting, updating, deleting, that is known as the privilege. We may authorize the users all, none, or a combination of these types of privilege on specific or specified parts of a database, such as relation or a view. When a user submits a query or an update, the SQL implementation first check if the query or update is authorized or not. So whenever a user submits a query or an update, then the SQL implementation that is available check out if the query is authorized query or not, based on the authorization that the user has been granted. If the query or update is not authorized, it is rejected. If any query or update that is not authorized, it is rejected then. So whenever we use the authorization, that means we can say that it's a privilege to find out whether the person is authorized, whether the data is authorized, whether to insert the new data, whether to read the new data, whether to update the new data, whether to delete the new data. So when a user submits a query on an update, the SQL implementation first check if the query or update is authorized or not, based on the different authorizations that the user has been granted. So if it is not authorized, that is it is rejected. So whenever whatever the query that is available, it is if it is not authorized query, then it is rejected. In addition to the authorizations on the data, users may also be guaranteed authorizations on the database schema. So there must be authorization that is also available on the database schemas, allowing them, for example, to create, modify, or draw relation. That is how to create, how to modify, or how to draw the relations. A user who has some form of authorization may be allowed to pass this authorization to other users or to withdraw an authorization that was granted earlier. So the ultimate form is the ultimate form authority is given to the database administrator. So there is a person that is available that is known as the database administrator, that has all the capabilities, that has all the abilities to manage the structure, to manage the database, to restructure the database, to provide the new users, that is restructuring the database, and so on. This form of authorization is analogous to that of the super user, administrator, or operator for an operating system. That is an authorization. Now first one is granting and revoking of privilege, that is how to give the authorization part or how to revoke the authorization part. So the SQL standard includes the privilege, that is the select, insert, update, delete. So there are four privileges. One is the selection, one is the insertion, one is the updation, one is the deletion. So there are four authorization that is available. So how to grant them and how to revoke them, that is how to get back the privilege, how to grant the privilege that is available. The SQL standard includes the privilege, that is select, insert, update, delete. The privilege, all privileges can be used as a short form for an allowable privilege. A user who creates a new relation is given all privilege on that relation automatically. So whenever a table is created, so automatically the privilege is available. So automatically it is assigned the privilege. The SQL data definition that is available, that includes the command to grant and revoke the privilege. So there is a grant, there is a privilege that is available, that is granted by the privilege. The SQL data definition language includes commands to grant and revoke the privilege. The grant statement is used to confer the authorization. The basic form that is available for the grant statement that is available, that is a grant privilege name on which part, that is on which relation, privilege to the user that is available on the privilege, that is on which part it is available on a privilege. So the grant statement that is available is the grant privilege name on the relation or the view name, whatever the thing that we apply the privilege, that is the grant privilege list on the relation name or the view name to the users or the role list. So whatever the grant or whatever the privilege that is available, that is given in this privilege list on the relation on the table that is invoked, and to the users to whom it is giving the privilege. So whenever the SQL query is used, whenever the SQL statement is used, it is automatically aligned or it is automatically updated, that is available in the database. So whenever new statement is uploaded or whenever a new content is available, that will be uploaded, that will be available. So a user who creates a new relation is given all the privilege on that relation automatically. So automatically a new privilege will be followed and automatically it is given the new privilege. The SQL data definition language includes commands to grant and revoke the privilege. So this is one of the, we can say, the syntax that is available for the privilege. The privilege list that is available that allows the granting of the server privilege in one block, in one common block, in one command. The notion of the role is covered later in section 4.6.2. The select authorization on a relation is required to read the tuples in the relation. The following grant statement that grants a database users, that is Amit and Santoshi or Satoshi, that select authorization on the department relation. So this aligns the, or this assigns the grant statement to only two persons, that is the user's name is Amit and the Satoshi, that selects the authorization on the department relation. This is grant select on. So this is a grant, that is a keyword that is available. So select on the department, that is on which we can say the table that is it is giving the privilege. So this is select on department, that is on the department table it is giving the privilege to the two persons, that is the Amit and Satoshi. This allows those users to run queries on the department relation. So these are the two persons that run the queries on the department relation. The update authorization on a relation allows a user to update any tuple in the relation. That is, the update is also available, or update authorization that is given or that allows a user, that is update any tuple in the relation. So if I want to update, if I want to, we can say the modify, update any information, update any table, any row in the relation, that will be done by the update authorization. The update authorization may be given either on all attributes or only some attributes. If update authorization is included in a grant statement, the list of attributes on which update authorization is to be granted automatically that is appears in the parenthesis, that is immediately after the update keyword. So whatever the keyword command that is given in the update variable, that is given as a update mention. If the list of variables, if the list of attributes is omitted, the update privilege will be granted on all attributes of the relation. This grant statement gives the users Amit and Satoshi update authorizations on the budget attributes of the department relation. This is grant update budget on department to Amit and Satoshi. So this is the grant statement that is given, that is updations on the available on the budget, updation that is update available on the department table to the two persons, that is Amit and the Satoshi. So what is the field name, what is the, we can say the column name that is updated, that is the budget will be updated on the table, that is a department table, to only two persons, that is the Amit and the Satoshi. The insert authorization is also available, that is how to insert the data, that is how to move the data, that is the insert authorization on a relation that allows a user to insert the tuples into the relation. That is how to insert the tuples into the relation. That is the insert privilege may also specifies a list of attribute, that is a what is a tuple, or what is a, we can say the privilege, or what is a different attribute, that is a list of attribute that is available to specify the attribute system that gives the remaining attributes default values. And next is the delete authorization. So one is the grant that is available, one is the update, one is the insert, one is the delete that is available. In the same way, delete authorization allows a user to delete tuples from the relation. So this gives a privilege to the tuples, or this gives a privilege to the users to delete the tuple from the relation. The username public refers to all current and future users of the systems. Therefore, privilege granted to the public are implicitly granted to all current and future users. By default, a user role that is granted a privilege is not authorized to the grant that privilege to another user. So any privilege that is assigned to one user is not authorized, or is not giving to the another user. It is worth noting that the SQL statement and mechanism that grants the privilege on the entire relation that is available. Now, it is very important that there is also a method to revoke the privilege. For example, if I am giving a privilege, if I am giving any, we can say the authority to one of the person, that there is a privilege that you can do this task. I can also opt the revoking of an authorization, that is to revoke an authorization we use the revoke statement. So for revoking purpose, there is a statement that is available, that is use the revoke statement. It takes a form that is almost identical to that of the grant statement. This is revoke a privilege list, that is revoking the privilege list on the relation name or the view name from the user. So this is the syntax that is used, that is revoke whatever the privilege, that is a read privilege, write privilege on the relation on the, we can say, the table name or the view name from the table or from the users or the role list. Therefore, to revoke the privilege that we granted previously, we write revoke select on department from Amit and the Satoshi, then revoke update budget on the department from the Amit and the Satoshi. So this is revoke whatever the privilege that is a select on the department from the Amit and the Satoshi. So this is select on, that is the privilege list on the department, on the table department from the Amit and the Satoshi. That is the select privilege will be taken out, revoking out from the Amit and the Satoshi. Next, revoke the update budget on the department from the Amit and the Satoshi. That is also used for the revoking the statement that is available in the budget. Now, next is the roles. That is, what are the various roles or what are the various scenarios that is available in the roles, that is available in the database. So how the roles are created in the database, that is the next topic, but I'm not going to take right now. First take a break, then moves to this topic, that is the roles. So let's take a break right now, then moves to the topic, what are the roles or how the roles are stored in the database. Let's take a break. Come back from the break. Now let's start the session again. So let's start with the next part, that is the roles. That is, what are the roles and how to create the roles in the database. So consider the real world roles of the various people in a university. Every instructor, every student must have a same type of authorization on the same set of relations. That is, if there are 4 relations, that is a similar type, that is the same set of relations have a same type of authorizations, that is same type of privilege that is given, same type of authorization that is available on the same set of relations. Whenever a new instructor is appointed, so whenever there is appointment of the new instructor, she will have to given all the authorizations individually. That is, she will give all the authorization part individually. A better approach would be to specify the authorizations that every instructor is to be given. So whatever the authorization that is available, that every authorization must be specified, or that every instructor is to be given, that is the authorization part, and to identify separately which database users are instructors. So whatever the roles, whatever the responsibility that is given, that is assigned, that is denoted to the different person, different authorization team, that will be given the authorization. So when a new instructor is hired, a user identifier must be allocated to him. That is, a user identifier means a user ID is allocated to him, and he must be identified as an instructor. Individual permissions given to instructor need not be specified again. So whatever the information, whatever the instructor, whatever the individual permission that is given, that need not be specified again. The notion of roles capture this concept. So whatever the notion of role, that is capture this concept. A set of roles is created in the database. So whatever the role that is created in the database. Authorizations can be granted to in roles. So whatever the authorization that will be available, that will be granted to the roles in exactly the same fashion as they are granted to the individual users. So whatever the authorization that will be granted to the roles, that it will be given in the same fashion, in the same manner as it will be given to the individual users. So if an individual user is taking some roles, is taking some authorization part, the same authorization part will be given to the group, to the role. Each database user is granted a set of roles that she is authorized to do. In our university example database, example of roles that could include the instructor, teaching assistant, student, dean, and the department chair. So whatever the role that is available to the instructor, teaching assistant, to the student, dean, and the department chair. A less preferable alternative could be or would be to create an instructor user ID and permit each user or each instructor to connect to the database using the instructor user ID. A less preferable alternative that is available. Any authorization that can be granted to a user can be granted as to a role. So any authorization that is granted to the user can also be granted as a role or to a role. Roles are granted to the user just as authorization are. So this is the same, that is a role. Just any user can get the authorization. In the same way, there is a role that is assigned to the authorization that is assigned to the users. Roles can be created in SQL as follows. So how to create the roles? That will be created in the SQL as follows. To create the role instructor, so roles can then be granted privilege just as the user can, as illustrated in the statement. So whatever the role that will be granted, privilege, or that will be given privilege just as the user can or just as the user can give the privilege. So roles can be granted to the different users. So this is grant select on takes to the instructor. So whatever the whatever the grant that is available, that is a select on will be available, that is take to the instructors. Right. So role can be granted to the users as well as to the other roles, as these statements show. So this is the grant, that is a dean to the Amit. So grant whatever the value that is given, that is a dean, is given to the Amit. Create the role dean. So whatever the authorization part, what's the authorization part? That is a dean. Grant the instructor to the dean. Grant the dean to the Satoshi. So Amit and the Satoshi will be given a different roles. So all privilege directly granted to the user or the role. So this is the direct granting of the role, direct granting of the privilege that is available. All privileges, next point says, all privileges granted to the roles that have granted to the user and the role. Note that there can be a chain of roles. For example, the role teaching assistant must be granted to all the instructors. In turn, the role instructor is granted to all the deans. The dean role inherits all the privilege to the role instructor. So this is just the definition, or just the meaning of this chain of the roles. And when the user logged into the database, the action that is executed by the user during that session have all the privileges that is directly given to the user. Then authorization on the views. That is, what are the various authorization that can be applied on the views. That is the authorization on views. In our university example, consider a staff member who needs to know the salary of all faculty in a particular department, say the geology department. So for example, whenever consider a staff member who needs to know the salary of all the faculties, or salary of all the, we can say, the participant that is available in a particular department, say the geology department. So this staff member is not authorized to see the information regarding the faculty in other department. So this is also authorization. So every salary or every employee salary is not visible to each and every one. So this staff member is not authorized to see the information regarding the faculty in other department. Therefore, the staff member must be denied direct access to the instructor relation. Suppose that the staff member issues the following salary. That is this is creating the view. That is, create the view the geo instructor as select the star from the instructor where department name equal to geography or geology. So creating the view, that is a instructor that is available as the select star that is available, and from the instructor where the department name equal to geology. This is one of the example. Now authorization that will be applied on the schema. So how the authorization will be applied on the schema? So the SQL standard specifies a primitive authorization mechanism for the database schema. So that is also providing the primitive authorization mechanism that is available for the database schemas. Only the owner of the schema can carry out any modification to the schema. So only the owner, that is the owner of the database, can only specify the, or can only disturb the, can only modify the schema, that is a logical design, such as creating, deleting relations, adding, dropping attributes of relation, and adding or dropping the indices. So this is the only the owner information that is available, that will modify the schema, such as creating, deleting, adding, dropping, and the indices relation that is available. However, SQL includes a references privilege that permits a user to declare foreign keys when creating the relations. The SQL references privilege is granted to the specific attributes in a manner like that of the update privilege. So this is one of the, we can say, the example, that is how the reference will be given. That is a grant references department name on the department to the Merino. So this is granting the references, or whatever the reference name that is given, that is a department name on the table department to which person? That is a Merino person. Now, how to transfer the privilege? That is, how to grant the privilege, or how to transfer with the to the another person. So this says a user who has been granted some form of authorization may be allowed to pass his authorization or his or her authorization to another user. So this is also a provision that the authorization must be passed to the other users. By default, a user role that is granted a privilege is not authorized to grant that privilege to another user. So if he wish to grant the role, if he wish to grant the privilege to another person, he or she can do so to pass the privilege on to the another user. Then we use the append the with grant option close to the appropriate grant command. So the appropriate grant command is used, and we can use the with grant option. For example, if we wish to allow Amit the select privilege on the department and allow Amit to grant his privilege to the other. So this is an example that shows Amit has a whole privilege. Now Amit wants to give the privilege, or Amit wants to give their privilege to the other person. So how it is written? That is a grant, then select on department to the Amit with that grant option. So this is grant, that is a select on. So whatever the grant that is available, that is a select on department to the Amit with the grant option. That is Amit now getting every option with the grant option. That is, he is giving the grant option to the another persons. Now how to revoke the privilege? That is how it is revoking. This is the statement that is used. That is a revoke select on. So whatever the whatever the we can say the ability, whatever the privilege that is available, that the privilege is select on privilege. So revoke the select on privilege department from the department table from Amit or Satoshi restrict. That is now revoking each and every information, revoking we can say the getting back all the privilege that is given to the Amit and the Satoshi. This is the cascade that can be used instead of the restrict to indicate that revocation should be cascade. Then the following revoke statement, only the grant option or only the grant option will be used rather than the actual select privilege. So this is revoke grant option for select on department for from Amit. Note that some database implementation do not support the above syntax. That is, there are some database implementations, there are some databases that does not support the above syntax. Instead, the privilege itself can be revoked and then granted again without the grant option. Cascading revocation is an appropriate or inappropriate in many situations. So whenever we cascade the revocation, that is inappropriate in many situations. Suppose Satoshi has the role of dean, grant instruct to Amit, and later the role dean is revoked from the Satoshi. Then Amit continues to be employed on the faculty and should retain the instructor role. How is that possible? Or how to grant the privilege with the grantor set to the current role that is associated with the session that is done by the granted by the current role. Now next is a summary, that is a summary of this chapter. So we have wind up with this chapter, we are finished with this chapter. Now first point says SQL supports several types of join that includes the inner join, outer join and the various join conditions. So there are two types of join expression that is available in the intermediate SQL, that is a outer join, that is a inner join, and the various join condition, that is how to join, like natural join, inner join, outer joins. Then second part says view relations can be defined as relations containing the result of the query. So whatever the relations, whatever the output, or we can say whatever the table that will be defined, that is defined as a relations containing the result of the queries. Views are useful for hiding the unneeded information. So whatever the unneeded information that is available, that is hide for the information, and for collecting together information from more than one relation into a single view. Then transactions are a sequence of queries and updates that together carry out a task. So whatever the transaction that will be given, that is a sequence of queries and the updates. Transactions can be committed or rolled back. When a transaction is rolled back, the effect of all updates performed by the transaction are undone. Then integrity constraints ensure that changes made to the database by authorized user do not result in a loss of the data inconsistency or data consistency. So whenever we apply the integrity constraint, that means the data is valid, and any changes that is made to the database by the authorized person that does not result in the loss of the database, or they do not result in a loss of the data consistency. Then next says referential integrity constraints ensure that a value that appears in one relation also appears for a certain set of relation in the another relation. That is a referential integrity constraint. Then the domain constraint that certify that whatever the value that is available in the domain that doesn't contain the null values. Then next point says assertions or assertions are declarative expression that state predicate that we required allows to be true. That is the assertion. Then the SQL data definition language also provides some built-in functions like date and time data types, integer data type, character data type, and the date and type data type, as well as the user defined data type. That is the data type is also available for the user defined. The next point says SQL authorization mechanism allows one to differentiate among the users of the database so far as the type of access they are permitted on various values. Next, a user that is granted some form of authority may be allowed to pass the authority, may be allowed to pass the privilege to another users also. Then last point says roles helps to assign a set of privilege to the user according to the role that the user plays in the organization. Suppose there are 4 departments: production, finance, sales, marketing. So the same or the relevant set of privilege will be applied to the production department, to the marketing department, to the finance department, to the sales department. So that will be the roles that will be assigned to the various privileges, or different privileges are available for the different roles, for the different assignment, for the different content. Then there are review terms that is available. There are join type, that is inner outer join. Then view definition, materialized view, view update, transactions. These are the various key terms that is available. Now there will be a practice question exercises that is available. That is, these are the practice how to do the these exercises. This is the writing the queries that is available. This is giving the syntax and you have to write the queries. Now these are the various examples like 4.2, 4.3, 4.4. Then intermediate queries. Then these are the various exercises that is available for this book, that is a bibliographic notes. Now chapter number 5, that is the advanced SQL. So we have covered with the introduction to the SQL, we have covered with the intermediate SQL. Now next is the advanced. I am just coming within 2 minutes. So the next chapter is chapter number 5, that is the advanced SQL. So it's your wish, Nelda. Shall I continue this chapter or shall I stop over here and continue this chapter in the Monday's class? So tell me, Nelda, shall I continue or I stop over here and continue this chapter in the Monday's class? Okay, Nelda. So yes, Nelda, tell me. Yes, yes, yes. Yeah. Just a minute. This is the method how to revoke the privileges. Yeah, just a minute. This is the method how to revoke the privileges. This is the revokes condition. Then this says the following revoke statement revokes only the grant option rather than the actual select privilege. This is revoke grant option for select on department from Amit. That is taking all the privileges that is given to the Amit earlier. So getting each and every privilege from the Amit. And how to grant them to the other person, that is also a privilege. That is how to grant them. This is that is a granting privilege to another person, that is also available. This is revoking. Yes. Yeah. Okay, so you are using the SQL or Oracle. It depends on the software to software. So if you are using the SQL, then this command will use. Simply write this command and press the F5 key. All right. So thanks a lot, everyone. For yeah. More practice is required. So thanks a lot, Nelda. Any other doubts, Nelda? Okay. So that's all today's session. Thank you so much everyone for listening me, and bye bye. Enjoy your weekend, and we will meet on the Monday with the new chapter, that is chapter number 5, that is advanced SQL. So bye bye. Enjoy your weekend. Welcome. Bye bye.